All right, let's assume we have a significant repeated measures ANOVA. All right, so the one-way ANOVA is significant. What do we know at that point? At this point. At this point, we only know that there are differences somewhere among our means, but we don't know where. It's just like the one-way independent ANOVA. All right, when one-way ANOVAs are significant, all it's saying is you've got something, now you're going to have to use a follow-up test in order to find out which mean is different from which. Now, when we used when we did a one-way independent ANOVA, we looked at post hoc tests, right? We looked at Chaffee, Tukey, LSDT, but those post hoc tests are not called post hoc tests for the one-way repeated ANOVA. Instead of being called post hoc tests, they're called pairwise comparisons. And they're pretty much analogous to doing an LSDT test, right? So these pairwise comparisons tend to be quite powerful, but they also carry somewhat higher risk of a type 1 error. All right, but we still use them. All right, so if the one-way repeated ANOVA is significant, all we know is that at least two of the means are different from each other. The post hoc test that is needed to compare means 2 by 2, a post hoc test is needed to compare the means 2 by 2 to see which ones are different from each other. So you compare mean 1 to mean 2, mean 3, mean 4, etc. You go all through all pairs, and you're going to be able to see which means are different from which. Just remember that the post hoc test for a repeated design is not called post hoc, it's called pairwise comparisons. Okay, so that's just reinforced here. And with the pairwise comparisons, you would need to look at the lab lecture, the recording of the lab lecture, to see how each mean is compared to every other mean. And it's the same, actually. The procedure on SPSS is the same, regardless of whether you did pairwise comparisons or Tukey, Chaffee, LSDT, the readout is the same. And so is the principle. All right, so what these pairwise comparisons do and post hoc tests is they take every possible pair of means so that you could see which means are significantly different from which. Now, this is just a point of clarification. I sometimes hear students say, this mean is significant. A mean is never significant. It's the difference between two means that is significant. So again, you might think that that's saying the same thing, but it's really not. What does it mean to say, oh, this X bar is significant or whatever? It's like, I don't know what that means. What these tests are doing is looking at differences between means, and then that difference can be significant or not significant. All right, so that is not splitting hairs from a research and statistics perspective. All right, well, guess what? End of chapter.